All right, this is the last, deviation from our standard neutral atoms, and we call them isotopes. All right, and these have a difference in number of neutrons. So by the end of this, you should be able to distinguish your standard neutral atom from an ion, from an isotope, and how to deal with the difference in neutrons. All right, so review. See if you can fill in the blanks here. This should be atomic number. This should be electrons. Those are equal when you're dealing with neutral. And then you should have 17, 17, and 35 minus 17 equals 18. All right, so here's how you deal with neutral atoms. We've actually already discussed ions, but isotopes are neutral, just slightly different. So what if you were told this? You had a chlorine atom with an atomic number of 17, but an atomic mass of 40. Recalculate your numbers. Let me know what you get. Hopefully, using the same rules on the last slide, you got 17, 17, and 40 minus 17, which equals 23. All right, so your neutrons are different. All right, so an isotope is an element that has a different number of neutrons than the one listed on your periodic table. All right, so for example, carbon-14 is a carbon with 6 protons and 8 neutrons. All right, your periodic table carbon is just your standard carbon-12, which has 6 protons and 6 neutrons. So the rules for calculating your protons, electrons, and neutrons are the same, but you're going to be given a different atomic mass than the one on the periodic table. All right, and actually, interestingly enough, those decimals on the periodic table, those are actually because all the values there are the average of all the isotopes of the element. All right, and there's usually one isotope that is more abundant than the rest, and that's why the value on there that we round to is going to be really close to our most common isotope. All right, so if you look at chlorine, all right, on the periodic table, you've got a mass of 35.45. We usually round that to 35, all right, and its most abundant example is chlorine 35. All right, to actually calculate this, you can do kind of a general approximation in the sense that you know that there's more. So 76% of chlorine is the chlorine 35. So you can kind of come up with, well, okay, my mass is going to be closer to 35 than it would be 37. But to get that actual 35.45, what you would do is you would take this 35 mass, 34.969, you're going to multiply it by the decimal form of this percentage, which is going to be 0.7577. I get that by dividing by 100. And you're going to add it to the other isotope mass multiplied by its decimal form of the percentage. All right. So we're grabbing a calculator quickly. This is something where you won't have to do an exact calculation like this. You can, especially with a multiple choice sort of question, you're going to be able to approximate pretty easily out of your choices. But you can plug it in like this if you want to. So 34.969 times 0.7577. So that's going to be 26.50 plus 36.966 times 0.2463 equals 9.10. add those together. I get 35.60. All right, which is pretty darn close to the actual average mass on there. What's going on is there's probably other isotopes that are in such a tiny amount that the text didn't even include them. All right, so that's one reason why you probably just want to use that kind of approximation sort of thing. We know that 75% is going to be this 34.9, almost 35 mass. All right, we have another 24% that's coming from heavier mass, so the average should be higher than this, but it's still going to be pretty close to that value. So one other thing to discuss is just some nomenclature type stuff. All right, so if I give you O, or O16, which is the standard mass on the periodic table, you can just assume that that's neutral and it's your normal atomic oxygen from the periodic table. All right, so 16 is going to be its mass. All right, some things to keep an eye out for is a number with a charge written to the top right. That means you've got an ion. Or a number written to the top left that doesn't match the mass, all right, that's on your periodic table. That means you're dealing with an isotope.